Welcome to Faith and Science. I'm Dr. John Ashton. We usually admire a beautiful sunrise or sunset, and the effects of the different colours can be, quite spectacular. Even in stormy, cloudy weather, when the sun breaks through, we can get quite spectacular effects. And also, just recently, I've seen some pictures that have been taken just by amateur photographers of the Milky Way, the stars in the sky. They've been really bright. It's been some particularly dark nights, and the array of stars are certainly spectacular. And in the Bible, in Psalms 19, we read. David wrote, the heavens declare the glory of God, and the firmament or the sky reveals his handiwork. And of course, we, so often we, hear these different articles about the Big Bang caused this and the Big Bang did that, and of course, in terms of we have terms of stellar evolution or the evolution of stars, these sort of things. But when I look at the problems and the unsolved problems in astronomy and physics, and of course in astronomy, when we're looking at very distant objects, not surprising, there's a lot of things that we don't know. But when we look, perhaps consider these issues, to me they point to the fact that the creation story in Genesis just makes so much more sense, that there was a super intelligent, all-powerful creator, God, outside space and time, a non-material God. And the Bible tells us that God is a spirit. He's not made up of molecules, atoms, and so forth, like our stars and planets and the universe is made up of matter. God's outside that. And of course, I've spoken many times how our minds, also our thoughts, are non-material. They're not made up of matter. And and so there's this real, to me, evidence of amazing design out there. When I think of the Milky Way and these stars, there's quite an interesting problem that when we look at the rotation of these galaxies, scientists using the laws of gravity can calculate the theoretical speed of rotating galaxies and stars. We look at their mass and so forth. And when we look at the predicted speeds that they should be from gravity as we move away, as we move further out in galaxies, as the outer the arms of the galaxy spin, the predicted velocity or speed is very different from the observed speed. So we have these major inconsistencies of what we can calculate based on the laws of physics and what we actually observed. And that's called the galaxy rotation problem. You can Google it and look it up on the internet. One of the other things, of course, just closer to home is the coronal heating problem of the sun. And that is when we at the sun, you've got the mass of the sun, and then there's this layer of gases around the outside of the sun that is just so much hotter than the sun's surface. So the sun's surface, we can measure it from radiation, just like, for example, during the coronavirus outbreak, people's temperature is measured using a radiometer. We can, without touching someone, we can measure their heat. And similarly, so we can measure the heat from the sun. And it's interesting, the surface of the sun is about 5,800 degrees Kelvin. So to get centigrade, subtract 273 from that, but they're the same size degree units. So anyway, it's very hot. But when we look at the outer corona, and this is this gaseous layer outside the sun, it in the order of 1 to 2 million degrees. So let's have a look at that then. So the sun's surface is 5,800 degrees above absolute zero. And yet this outer layer, this corona, is 1 to 2 million degrees, and sometimes in some areas gets up to 10 million degrees. Now that is just phenomenally hot, really phenomenally hot. When we think about, you know how hot boiling water is to get a scald, it's very painful. That's only 100 degrees. And if we look at the flame, the temperature of most hot coals in a fire, you're probably around about 1,000 degrees. And if we look at the melting point of iron and steel, you're looking up at about 1,500 degrees. And so when you think of something 5,800 degrees to the surface, but then getting up to 1 million degrees, that's 1,000 times hotter than 1,000 degrees, which is pretty hot, the glowing red coals. But there's an interesting problem there in that, how does it get so hot? You see, if the surface heat is just radiating out, then you can't make something, if you have an object radiating heat, second law of thermodynamics says that you can't make something hotter outside, so you can't accumulate heat. In other words, in your light bulb there, your tungsten filament's glowing at about 2,000 degrees centigrade. So you can't, and when you touch the outside of the bulb, it's not that hot. I mean, it's very hot, but it's not that hot, and you can't make it hotter than that because heat energy decreases. And it just can't self-concentrate. So you can't have a steel bar, for example, and then suddenly all the energy in that bar, which is above absolute zero, so absolute zero says it's about minus 273 degrees. So if we have a temperature of 20 degrees, then we're 293 degrees above absolute zero. So we can't suddenly have it that you have a steel bar, and you can't suddenly have it that the centre of the steel bar goes down to near 0 degrees and the outer edge of the steel bar then accumulates all the heat and becomes red hot. That doesn't happen. So this becomes a real challenge. How can you make something hotter? How the heat energy just can't be radiated out. You can't radiate heat energy out and it become hotter. It's going to become less. And so how this outer layer of the sun gets so hot is still one of the unsolved problems that scientists are trying to figure out how that happens. And there's all sorts of theories about whether or not these gases out there that are now at 1 million degrees are heated somehow by magnetic fields, causing massive collisions. And generating heat that way. But it's an amazing phenomenon, but that's what our sun is doing. And, of course, our sun out there, it's interesting, when we look at the creation account, God created the earth first, and then the sun was created on the fourth day. And the sun provides a lot of interesting environments for the earth. For example, it provides the gravity that holds our little solar system together. So it's almost the picture I have, and I know it's different to how the Big Bang model would have us say that the sun formed out of a condensing cloud of gas and so forth. But we know that the laws of physics, that gases just don't, clump together. The gravitational attraction just isn't strong enough. You have to have something that pulls those gases together. in the first place. But of course the standard model says that this happened and that the sun formed in the centre and then all the planets formed out around it. But the picture God paints is that he created the earth and then he created the sun and the moon around the earth to sort of balance the earth out and produce tidal effects on the earth that would clean out the lakes and cause this movement of water on the earth and other effects on the earth. And then he created the sun, and it's almost as if the sun provides this gravitational setup to allow, and the stars. So he created this environment for the earth, which we know as the universe, and set the sun up. And of course, if you look at it from this perspective, we see the sun is set up and we have around the earth these different planets created. And of course, the outer planets protect us from objects flying through space and this sort of thing. It's a really interesting balanced system, and the earth is just at the right distance of the sun. But it's the sun's gravity then that holds the solar system together and keeps the planets in their particular orbits. And then there are electric currents in the sun that generate really strong magnetic fields that are actually carried out into the solar system by what we call solar wind, which is a stream of electrically charged gases that move out from the sun in all directions. And it's these connections between the sun and the earth that actually drive our seasons, are responsible for ocean currents, the weather, climate, radiation belts, and some of the really special lighting effects that we observe like aurora and so forth. Now, the sun has some interesting properties in that while it's in the centre of our solar system, compared to all the other planets, it's huge. It makes up 99.8% of the mass of the entire solar system, according to a NASA website that I was reading. That's amazing. But there's also some interesting properties. At the equator, at the equator of the sun spins around, makes one complete revolution about every 25 days. But at its poles, the sun rotates once only every 35 days. So the outer parts of the sun, and it's a giant gas ball really, the sun is a giant gas ball that is spinning, and its outer parts are spinning at the equator, is spinning faster than at the poles. And according to the NASA site, it's the sun is a ball of gas that's about 92% hydrogen. Of course, hydrogen is a very light gas. It's a very simple element, one proton in the nucleus and one electron orbiting it. And, of course, you can have heavier elements with neutrons. You can have deuterium and so forth, and tritium, but they're just isotopes of hydrogen. And then it's about 7.8% helium, and then there are some minor elements there. But the outer surface of the sun is more like about 75% hydrogen and 23% helium. And that's because of these fusion reactions where the atoms are combining together, being forced together under such gravitational fields that they are actually creating a new nucleus, and the leftover energy in that fusion, the difference in nuclear energy is being released as heat. It's an amazing reaction, fusion. It occurs when the nuclear of the centre of atoms are actually fused together, and the leftover, as I said, energy as a result of the different mass combinations and nuclear forces is released as energy, and that's how the tremendous amount of energy is being released, at least to the surface of the sun. But as I said, scientists still don't know how these ultra-high temperatures of millions of degrees are being created outside. Although they do estimate in the centre of the sun as well that the temperature is very, very high. It's interesting that that energy that the sun produces really through a number of mechanisms supports life on Earth. It generates the sunlight that is used to provide the energy that in plants splits water. So plants have a little machine in them, a little molecular device that can absorb energy, split water into hydrogen and oxygen, and then combine the oxygen and the hydrogen with the carbon dioxide that the plants take in, and form carbohydrates, which are the sugars, and become the food for life on Earth. It's interesting that they believe, again, as a result of fusion, that the sun's core is up around about 27 million degrees. This is right where these fusion reactions are taking place. Then when it gets to the surface, it's cooled down to about, as I said, 5,800 degrees. And the estimate of the temperature at the core, of course, is based on calculations based on fusion reactions. But this still doesn't explain how the outer corona can be 1 to 2 million degrees. Because, as I said, once it gets to a temperature of 5,800 degrees, it can't re-increase in temperature again. So these are some fascinating, interesting facts that I think about the sun. The diameter of the sun also is huge. It's about 1.4 million kilometres, or 864,000 miles, which is nearly 110 times that of Earth's diameter. So it's about 110 times the diameter of Earth. And its mass is about 330,000 times of Earth. So it's interesting. The immense size of this gas ball is just hard to believe, and yet it's not one of the largest suns. You know, when you look out, as they look out into outer space, there are much larger suns. It's interesting if you go on Wikipedia and look up about the sun, which I did. It has slightly different figures for the mass of the sun. It says that 3/4 of the sun's mass is hydrogen, and about 25% helium. But my understanding is that may be really related to the surface of the sun. But it's interesting how these two authorities, NASA and Wikipedia, have those different figures. When they look at when the sun was formed, they say the sun went through some stages, and there's a very interesting problem with the Big Bang model for the sun. It's called the faint sun paradox. And again, this is something you could look up on the internet, on the astronomy sites, the faint sun paradox. And this paradox is a problem that describes the apparent contradiction between the observations of liquid water in the early Earth's history and the astrophysical expectation that the sun's output would only be 70% as intense during the time that the Earth was being formed. And this was an issue that was raised by astronomers Carl Sagan and George Mullen back in 1972. And so essentially what they're saying is that according to the standard Big Bang model, about 3.8 to 2.5 billion years ago, as they model the sun's development, the sun was only about 3/4 as bright as it is now. So this is as they work things out from the Big Bang model. But such a weak star would not have been able to sustain liquid water on the Earth's surface, and thus, according to their model, life should not have been able to develop. But again, as scientists look, the geological record demonstrates that the Earth has remained at a fairly constant temperature throughout its history, and that the young Earth was somewhat warmer than it is today. And of course we know that because we find, the remnants of corals and forests down in Antarctica. And so this is a major problem. So at a time where, if we have this Big Bang model for the sun, it just doesn't fit that the Earth could have been as warm. And this is a major, major problem. And I think as we look at these issues that come up, there are so many issues like this, like the faint young sun paradox, that point to the creation model in the Bible fitting. It works. It really fits the science that we observe today about the sun. Another fascinating aspect of the sun is the sunlight. And this is what we, wake up to. The morning we go outside on a sunny day. We generally feel pretty good on a sunny day. And I think we often miss the sunshine after we have a number of days of cloudy weather. Matter of fact, in some countries, they have a condition called SAD, seasonal affective disorder, and people can, get depression and so forth through not being able to experience that bright sunlight. And so sunlight has a number of health properties. It's, of course, the sunlight essentially is the black, sort of what we call the black body radiation from the sun, corresponding to its temperature at about 5,800 Kelvin. The sun emits a range of different types of electromagnetic radiation. It produces some gamma rays as a result of the nuclear fusion process, and these can then become high energy, really high energy photons. There are also gamma rays from solar flares, and there are X-rays produced. And of course the light that we get on Earth was made up of the ultraviolet light and visible light, and then there's infrared light. And of course infrared radiation is that radiation that carries heat. That's where when we go out in the sun and we feel the hot sun on us, that's the infrared radiation. Of course the visible light is what we see, and we see it as sort of almost sunlight being slightly yellow. It's generally, if people want to paint sunlight or refer to it, it's got a bit of a yellow tint, but it's actually pretty close to white. And then, of course, there's the ultraviolet light, and we know that the ultraviolet light is the one that can cause damage to skin, particularly ultraviolet B and C. But ultraviolet B is so there are three different types of ultraviolet light. It just really refers to the wavelength range of that particular type of ultraviolet light. And they have slightly different biochemical reactions or effects on living matter. But in particular, ultraviolet B is the form of ultraviolet light. When it hits our skin, it's responsible for producing vitamin D. And so this is where we have the issue now that we need to protect ourselves from getting skin cancer or damage to the DNA as a result from the sunlight exposure, versus the fact that we need to get sunlight onto our skin to produce vitamin D, which is an important vitamin, particularly for bone health and the general development of and general healthy development. One of the reasons, of course, that we have a lot of the skin cancer problems is that the ozone layer, so this layer, a special layer of gas ozone is 3 oxygen atoms combined. The oxygen in air is 2 oxygen, but ozone is 3. And this absorbs a lot of the dangerous radiation that's coming from the sun. But our number of refrigerants that we've used, chlorine gas, a number of other chemicals that we release into the atmosphere has caused major damage to the ozone layer in large regions of over the surface of the Earth. And in those areas, this allows more of the damaging ultraviolet light to get through, and of course the potential for skin cancer increases. But on the other hand, sunlight plays an important role in our health in terms of the light actually entering our eyes can travel down a little optic pathway, a little optic canal that actually takes the light from our eyes physically down to the pineal gland and in the brain. And this sunlight then helps the pineal gland regulate such things as our blood pressure, our cholesterol levels, our blood sugar levels, the menstrual cycle in women, and so forth. So this sunlight is actually, very, very important. And it's interesting how, again, life on Earth is attuned to the sunlight, this light that is produced by the sun. And I think this connection between life on Earth and the sun again points to a created system, not something that arose randomly by chance. All these things, in my mind, point to little clues that the creation story fits. The creation story that we find in, or account that we find in Genesis, really fits the scientific data on what we observe today on our planet. This gives me confidence that the Bible account of God creating a new heaven and a new earth is feasible and realistic. And this also gives me hope. We see the social problems, the health problems in the world, the growing problem of deforestation, pollution of the oceans. All these things point to the limitations that we have on our planet, not to mention the growth in the Earth's population. These are all signs that we are heading for a crisis situation. And the Bible talks about that too, and talks about how that will be the situation just before God returns to earth as Jesus Christ. But praise God, the Bible outlines the plan of salvation for us. You've been listening to Faith and Science. To re-listen to these programs, remember you can Google 3ABN Australia, or one word, .org.au, and click on the Listen button. I'm Dr. John Ashton. Have a great day.
You've been listening to a production of 3ABN Australia Radio.